Great. So we are going to restart the session after coffee break. So we now have Fatima, who is here from IAG. So she's going to give us a talk on everything you want to know about air pollution and are afraid to ask. Right?
Okay, thank you for the introduction. And thank you for coming here. It's a pleasure to see all of you, and also for me that now it's the opportunity to have older friends, people that work with me so many years, and that help to prepare this presentation, because many of the results that is a combination of work that have been done here for many years, and well, this title is really very interesting, what we know about air pollution. And it's nice because you can ask, because we have many people here that can answer. Then I feel comfortable because I can ask the help of people that work directly with the data here, because we have been studying air pollution for many years. We have a group here, and our group is more related to measurements and to modeling air pollution. And more recently, we started trying to work with other aspects of the problem, more connected to the other data related to mobility, accessibility to work, and air pollution. I will show at the end. Then we are going more from this general data to local, to the aspect of the human exposure also. And we have been done work also on emissions factor from cars and from trucks, and this is also important, and then we can discuss. After my presentation, we are going to have the presentation by Lucia Guardani from CETES, from the Environmental Agency. Then it's the moment we can discuss a lot about São Paulo air pollution. Well, I am going to try to talk about the sources, the evolution. We prepared a report that talk about the 30 years of air pollution data, and I will show this data. Well, the other presentations all the presentations talk about the position and also the main characteristic of our metropolitan area. What I'd like to show here is that we are not far from the sea when we are in a line, but we are above 700 meters above the sea level. Then we have this special circulation here, and then we have the Atlantic forest here. And also we have some mountains also here, and then it makes the circulation specific in this urban area. And what makes our so special is that we are a big city. We have, for the metropolitan area, more than 20 million inhabitants, a large fleet, automobile fleet, and we have some industrial plant, but with time, the participation of the industrial emissions in the air pollution is decreasing, as many works are showing. And also, we are having this spreading of the urban area. This is a picture by a friend, Edmilson, that's here. The meteorological conditions, we have the worst events in the winter time now, this, because we have this dry season, and in the morning you can have these radiative inversions. That this week is a typical week. We are going to see that the temperature will increase during the day, then we are going to have these skies with very few clouds, and also we are going to have during this week the air pollution getting worse. Well, this is a paper published that makes some point. That is a collaborative paper, and we have this this is like discussing the air pollution problem. And what we have here in São Paulo, it's most problem related to the particles and to the secondary pollutants like ozone. That ozone is formed by these primary emissions of NOx and hydrocarbons that comes from most here in São Paulo from the mobile source, and then we have this formation of the secondary organic aerosol and inorganic aerosol that I'm going to show later. When we look to this official inventory for the emissions for this CO, hydrocarbons, NOx, and particles, we see that in red and in blue we have the mobile, the emissions by the mobile fleet by using the gasoil and the ethanol, and in green the diesel. You are going to see that for most of the pollutants, most of the pollutants are emitted by the mobile sources. Only the participation of the industry is small. Only for NOx is more significant. And for particles, for PM10, we have also this secondary aerosol that's more related to the fine particles. Then we see the high participation of the mobile sources in air pollution. When we go to the mobile, what we have is a huge number of cars. Most of them is light vehicles, 85%, that runs with gasoil, that is gasoline with ethanol. 2% is old cars that are poor ethanol. Nowadays, most of the new cars, they are flex fuel, that they can run in proportion of gasoil or ethanol. It increased in the last years. Then we have half of the light vehicles running. This is passengers' cars running flex fuel, can choose the fuel. And 2% of these passengers' cars are diesel. This 3% of heavy diesel here, it's trucks and buses. And although the number is small in terms of proportion of the total fleet, the absolute number is high, and we can say that the impact of all these emissions in the city is a great impact. We saw in NOx emissions and also the emissions of particles and the formation of particles in the atmosphere. And also another problem is the huge number of motorcycles that you are going to see all over the city. It's because of the traffic. Then we have a lot of motorcycles to deliver goods, and people choose to go to work using motorcycles. We have this characteristic of having a lot of ethanol being burned to the atmosphere. And one area of our research is to analyze the importance of using ethanol as for the formation of the secondary pollutants in the atmosphere. This picture shows also, it is a report. It's a paper that makes a report of the emissions the concentrations in São Paulo for the last, it starts 82, this figure here. What we see is the increase in the number of cars, in the absolute number of cars, the decrease in the number of cars that run with ethanol, the increase in the number of cars that use flex fuel vehicles. But when we look to the concentrations, we'll see that CO concentration has decreased. This is possible to see here. Particles also, PM10, we have a decrease in the particles and SO2. And what we have here is a response for the programs that were implemented for reducing the emissions. It's in all over many cities in the world. It is working like that. You are having better engine, and then we are reducing the emissions from exhaust, most from the exhaust system, also for NO2, but we can see that for ozone, the concentrations are not decreasing, and this is an important aspect, and we have many works being done trying to evaluate if it's the impact of ethanol or if it's the impact of gasoil, or which is the most of them are leading to this, not an increase, but at least not the decreasing of the concentrations in the atmosphere. Here it's better to see this variation of for instance, for NOx, for particles, PM10, also for CO, and this is the behavior of ozone, this average concentration for the last 30 years, more or less. The data that I'm showing is from CETESB, is average concentrations based on the air quality stations from the environmental agents, that Lucy is going to show the air quality stations, the position of the air quality stations. Here is the average concentration for the air quality stations that are in the city of São Paulo. This picture is it's taken from the report from CETESB, and we have the concentrations of PM10 in the metropolitan area in the last year, 2017. And this is the maximum daily concentrations, and this is the average concentration for the year. And we have air quality standards that are different from the guidelines from World Health Organization. But you see that we have, even for our standards that are not so restrictive as the guidelines from World Health Organization, we see that we can have high concentrations. I put here, this is a figure that Regina prepared, she is here. But I put some data here. This is the same data that we saw in the other picture, but the only difference is that this is PM10, this is the standard in São Paulo state, and this is WHO guideline, that is the yellow one, and this, the red one is our standard. And the only thing different here is that I go from the lowest concentrations to the highest concentrations. And when we see this, we note that the highest concentrations, they are not in the middle of the city. This is important here in São Paulo. This data is only for the city of São Paulo, not for the metropolitan area. Then we see the highest concentrations are Osasco, that is in the west side, close to us now. But this other place, like Grajaú, is in the south of the city. And this is Marginal Tietê. It's very close to this marginal, to this big avenue where we have a lot of trucks. And you see that we can have highest concentrations not in the middle of the city, not in downtown exactly, but in the periphery or here in the Marginal Tietê. That is also where we have more trucks. You see, this is for PM10. This is good to know because we say that everybody is exposed to the bad air, but at some places in the city we are more exposed to the highest concentrations. And for PM 2.5, that's the fine particles, particles that can go deep in the lung. Also, we have here, this is São Paulo standard, this is the guidelines from WHO, and you see the same happen. The highest concentrations are in the west part of the city, Guarulhos, that is the east part, close to the airport, to the Cumbica airport, where you come, the airplane. And Santana is the north part of the city. Then you have the highest concentrations in the extremes of the city. This is something that we should analyze with more careful, because these are more related to the big avenues and to the big roads that we have crossing, not crossing the city, but making this ring in the city. Okay. Well, to decrease the concentrations of the pollutants in the city, what was done was some programs. These are the main programs. We have here this, rodízio, that's when we have a day in a week that according to the last number in the license plate, we are not allowed to go with our car. Yeah, it's working here. Also, we have this PROCONV that was a program for controlling the vehicular emissions that started in '83. The standards for the emissions here is the same, more or less the same as in the United States, but when more or less 10 years late. And more recently, we have this program for controlling the emissions by the motorcycles, because they can contribute a lot to the pollution in the city. Then our biggest problem now is the particles, the fine particles, that we know that they are really bad for health. And we have some direct emissions, but most are coming from secondary formation. That is one subject that we are studying a lot. Another problem is the ozone. And ozone, we are studying the impact of the ethanol as a fuel, the contribution of the gas oil also, and the evaporative emissions that we think it's a big problem because we are controlling the exhaust that's coming directly from the car, but not the evaporative emissions. Here it's the composition of the particles. As the question is what we know, we also have been measuring particles for many years. It's not only works from here. This in the past was some work that was done in the Physics Institute in the 80s, and then we see here that the sulfur concentration, this is a log scale, and then we can notice that the sulfur concentration decreases with time in the particles. Also, we have that the lead in the particles decrease substantially because this is 10 to 3 and 10 to 2 and 10 to 1, and then almost more than 10 times. Also vanadium that was related to burning of fuel in industries, oil in industries. Then we see also that the concentration has decreased with time, showing that what we have is the decrease in the participation of this of the industries shown by this behavior of the vanadium, and also the decrease in the lead from the fuel. When we look to the composition of the particles, we see that we have we see that when we look to the concentration of the particles, we have that organic compounds are half of the fine particles, and elemental carbon, that is most this black carbon soot, is 20% of the fine particles. And then when we look to this part of the composition, because the metals, they are only less than 15%. They are important because they can show us the evolution of the sources, but most of the composition, they come from the organic and the elemental carbon, are carbonaceous particles. When we look at the composition, we see that for the elemental carbon, 90% is from vehicular source, 10% is from biomass burning. This is another thing that we have the impact here is the biomass burning. And the organic carbon comes from secondary carbon from vehicles, and also primary organic carbon from biomass burning and also from vehicular emissions. And when we see the measurements of elemental carbon and organic carbon, we notice this, that when we are close to the street canyon, for here is a downtown, a park, university. It was a work made by, here it's a student from Physics Institute, and also Guilherme Pereira, that's here. I put both data, showing the great participation of organic and elemental carbon in our data, and more closer to the emissions near streets. And why it's so important, this carbon, we have some reports from the Health Organization showing that black carbon has a great impact in the health, bigger than the impact of, it can be a good tracer for the impact of particles in human health. Also, we did some analysis. A student is making analysis of a fraction that's bioaerosols. The contribution of biological material in the composition of the particles. She is analyzing the pollen, and now is trying to analyze other biomaterial that is part of the particles also. That's part of this organic carbon in the particulate matter. And for ozone, these aspects that I put before, the importance of gas oil or ethanol for the VOC emissions and also for the ozone formations, then analyzing the more reactive compounds, and this formation of the secondary aerosol. This figure, it is also prepared to show this. we saw the figure of the average concentration of ozone for many years, but this is the calculation of the first maximum, second maximum of ozone since 1996 to 2006, and here from 2006 to 2016. What we note here is the decrease, the behavior of decreasing the maximum each year, the first and the second maximum, and when we here since 2006, more recently, a slightly increase in the concentrations, in the concentration of the maximum value of our ozone. Concerning some ozone precursors like formaldehyde and acetaldehyde, this is a paper also prepared by, this is Nogueira, about the concentrations of these ozone precursors. They show that there is a decrease in the concentrations of these both ozone precursors, although our concentration is much higher than the concentrations compared to California, for instance, for both these ozone precursors. That is the emissions from burning, mainly from burning ethanol, and also we have some other secondary formation of formaldehyde in the atmosphere. But we have some search that we try to analyze better, that we don't have correct numbers, like these evaporative emissions during refueling, some emissions by using of solvents, that we have a lot of VOCs, and the biomass burning, that we have many different studies that I can show, but now I'm not going to show, about the biomass burn, if we have vegetation or connected also to the burning of sugarcane, and also the burning of the forest in the north of the country. I put here to try to explain. We have measurements and more data about the exhaust emission, but we don't have enough information about the refueling emissions, for instance, because here when we are refueling, you have a lot of vapor of all this VOC that goes to atmosphere, and also some evaporative emissions when the car is hot, and then in the morning or during when it's in the parking with high temperature. Also, the biomass burning, I will show here. We have some biomass burning in the city for cooking, mainly in the restaurants, and also we have biomass burning from the central area of Brazil and also close to the state. I put this recent map that's active fires in this year from July 1st to July 31. It's a site where we can find the number of fires in all the world, and I took this for the state of São Paulo. We can see that we have many points of biomass burning, and now when we have wind that comes from inland, from the northeast of the city, of the state, we can have all this contribution to the city. Then we can have the contribution from more regional scale, like from the north of the central of the country, but also we have many contributions from the state of São Paulo. Some are related to the burning of the sugarcane leaves. Still now we have some burning of the sugarcane leaves during the harvesting of the sugarcane. This is important. So we have some conclusions that I can say here, that we note in these 30 years that this program for controlling the emissions was effective in reducing the primary pollutants, but we are not considering other important sources. We don't have exactly the data about the emissions. And we also are trying to evaluate this contribution from sources outside the city. And also, I put here related to the carbonaceous particle. But there is one thing that is important. We are developing many work with modeling that I'm planning to show in other day, related to evaluating the emissions and the formation of the secondary organic and the inorganic aerosol with modeling. But I also like only to say two words about the project that we are now. It starts 2016. It's a project that is more related to what we are doing. We can do in this project in Klimapolis and City Lab. It's not related to the measurements for the city, but we are trying to study the impact of people that are exposed to air pollution inside when they are commuting, inside the buses, metro, subway, and also cars, and more recently also the bicycles. And this project is FAPESP, ERC from England and from the Netherlands. And this proposal, it's investigation these mechanisms of underlying disparity and social injustice in job accessibility and air quality in the metropolitan areas. And then we are comparing São Paulo, London, and Hampstead, that's closer to Rotterdam. For London, the coordination is from Professor Prashant Kumar, that's here. He can explain something about it if need. And we are now, students is measuring their pollutants, and we have also a questionnaire about the way people feel about being exposed to air pollutants, about the time they spend from the house to the jobs. And it's very interesting because what we see is that the concentrations can be the same in different ways of commuting, but what we know is that people can take many hours from their homes to the jobs, and then when they are doing this commuting, they are exposed to high concentrations for long period of time. I will put here, we have even a website. This is the project. The street is for accessibility, social justice, and transport emission impact in transit-oriented development strategies. I only put here, this is from the work that is being done by Veronica, that is her PhD. This is a selection of routes to see the exposure to the pollutants. This is the selection of buses that were analyzed. Then the idea was to go from north to south and from east to west, from different kind of transportation. The concentrations are here, but I'm not going to discuss. The measurements were performed with portable samplers for black carbon and for total particles. Also, some sampling with for bicycles. These are the samplers. It's a small one for PM10, PM2.5, and for black carbon. And then we can discuss more if needed. This is the students making the measurements. And this is some bicycle lines, the Paulista, Anhangabaú, and Ibirapuera, and some concentrations in different kind of bicycle lines. For instance, we have some special lines, and other lines are not dedicated to the bikers, to the bicycles. Then that's what I'd like to show. Thank you. Foi muito longe, né? Desculpa.
Great. We have time for a couple of questions.
Just a general question about the CETESP. Sorry. Okay, thanks. Hello. It's just a general question about the thresholds, the air quality thresholds from CETESP nowadays. I know that São Paulo for some years has been trying to lower the thresholds and had this interim
Yes.
thresholds. And is São Paulo now at the final objective of the thresholds, or at what stage is it?
No, I can show here. When I put this, São Paulo start to have different standards. We have the standards for Brazil. Lucia, I think Lucia can explain better then. But we have our standard. Here it's possible to see. In São Paulo, they established to have like for instance, here is for PM10 annual average. That's for the country is 50 micrograms per cubic meter. No, and for the state, the first level was to decrease to 40 nanograms per cubic meter. Micrograms per cubic meter. This is the first level. The idea is to reach the last level that would be the recommendations, the guidelines from WHO. But this is still in the first level. Then there will be a second level that's to decrease to, you see, this is the second and then the third level. It's going, the idea is that the concentrations will be decreasing until reach. But it was established in 2013, and it was expected that after 2 years, we start discussing the second level, but it's until now it's in the first level. But it's changed for PM10 and also PM2.5 that I put here. PM2.5 is to end, and not only in the state of São Paulo, I think in Espírito Santo also, they already have this standard for PM2.5. And the guidelines is half of this value. But at least now we have a standard for fine particles. That's very important, yes.
Yeah, thank you very much for the interesting presentation. I was interested in the second part, the new project, and how this measurement data, this new type of data, which is pretty much bottom up and so on. Are there any thoughts on how to integrate them in longer term data archives? I don't know. You know, I mean, it's not just a stationary thing where you get constant data that you can collect and reuse, but it's, you know, project based and probably only a few times during the project.
Yes, the measurements, I don't know if it's exactly this, but the measurements were performed at some period of the year, and then it's not a statistical it's a significance for all the year. The idea is to repeat the measurements, to have more statistical data, but what's interesting is that it's all the measurements, they were performed in the same conditions, like not raining, and then keeping this more or less the same meteorological conditions. And the measurements were made inside the transportation system. You know. And then you can see that the concentrations varies, and the concentration varies a lot. But usually we have these higher concentrations when it's at some conditions in different ways. For instance, you are going to have higher concentrations of black carbon in the buses as expected, because it's exposed to the other buses that are on the road and the tracks. And we have this comparison. Usually we have these highest concentrations in buses and then metro and then cars.
But like, as of now, it's not planned to maybe install measuring devices inside the buses that can
It's not an idea. I know that there are people thinking about putting measurements device, but not inside, but outside to have these concentrations. Because we want to have a high resolution data, and there are different groups working with this high resolution data to have a better map of exposure of people in the city.
So final quick question.
Yeah, hi. Thank you for your very interesting and informative talk. My name is Catherine Zengerling. I'm from Hafen City University in Hamburg, and I'm a lawyer. So a government related question, how closely do you work with the local government, and are you collaborating in new tries, for example, to get down the PM 2.5 numbers that are like higher than the WHO standards pretty much everywhere there, but even above the São Paulo level for this one place?
Yes.
Is it like, how closely do you work with them, and how closely are you involved in policy design and later on in the measuring whether the policies have been successful or not?
Yes. We have, I think here in São Paulo, we are working together for many years now. this data from the others project, we have some even formal collaborations, like through a project funded by FAPESP. We start having this, they call public policies, for instance, with this kind of trying to work together. And many data that we have, it's obtained together, and then we share this knowledge. But I don't know if it's effective in the end of helping to implement some regulations. This, I think, it's quite complicated, because you see, when we have these concentrations that are above the air quality standard, it's very difficult to implement, because we know that the main reason is the mobile source. Then it is difficult to implement regulations, but what we can, with what we have, help is in providing informations and showing this that it can be improved if you have some. Now we are trying to do this, trying to find what can be done to improve or to help improving the knowledge about the air pollution and what can be done. Yeah, we have been working together.
Yeah, and I think this is something that we work within Klimapolis, trying to engage the stakeholders to government level, to the science, right? To put the knowledge out there. I would like to propose a change in the agenda, because Camila would talk now on local action for climate change mitigation, but Lucia is going to would talk after that on the CETESB activities, which is very much related. I don't know exactly why I left the talk not immediately after, but anyway, is Lucia here? So would you give your talk now? There we go. So